Hello, welcome to Chapter 13, Lesson 9. Today we're going to be talking about area and perimeter. So two rectangles can have the same area, but a different perimeter. So how can that be? Same area, but different perimeter. Let's think about this. Like, let's say our area equaled 12 square units. Okay, so let's picture this. 12 square units. What factors, remember factors are numbers we multiply together to get a product. What factors can we multiply together to get 12? We could multiply 6 times 2, 12 times 1, or 3 times 4. All of those numbers we can multiply together to get 12. So that means, right, because to get the area, we multiply a length times width. So if I was going to draw this rectangle here, I'd have a width of 2 and a length of 6. This rectangle here would be a really skinny baby rectangle because its width is 1 and 12 is its length. And then this one here would have a rectangle, be more like a square-ish, but not a square, but kind of more stout. That would have a width of 3 and a length of 4. Now if I multiply 12 and 1, let me change my color here. If I multiply 12 and 1, I get an area of 12. If I multiply 2 and 6, I get an area of 12. And if I multiply 3 and 4, I get an area of 12. So here is a great example of how I can have 3 different rectangles with different widths and lengths, but I still have an area of 12, and these would all have different perimeters, right? So let's dig in deeper. I took way too long introducing this, but let's dig in deeper and do some problems. Example 1. Elizabeth will build 2 fences, one surrounding each garden shown below. How much area does each garden cover? How much fencing will she need? So fencing is perimeter, right? So this would be perimeter. I'm going to put a P for perimeter. So we're finding area and perimeter of each of these gardens, right? Okay, so area equals length times width. Okay, so I need to multiply 6 and 2. That's 12. Area of garden 2, area equals length times width. Here's our formula. So I need to multiply 3 and 4, which is 12. Okay, so same area, but are those the same types of gardens? So let's find the perimeter. So the perimeter of garden 1, we have to add 2 6s because this side would be 6. And then 2 2s because this side over here is 2. So I would get 12 plus 4, and 12 plus 4 is 16 feet is our perimeter for the first garden. Let's see what our perimeter for the second garden is. 3 and 4 is 7, 3 and 4 is 7, 7 and 7 is 14. They have different perimeters, but the same area. Garden 1 needs 16 feet of fencing. Garden 2 needs 14 feet of fencing. Crazy. Let's see if there's any more examples like this. 2 rectangles can have the same perimeter, but different areas. We already talked about that. Oh, no, we did not. We talked about same area, different perimeters. Now we're going to say same perimeter, different areas. Let's dig into this. Right, so perimeter we think of as fencing. So the same amount of fence, but we're covering a different amount of space. So draw and label a rectangle has the same perimeter as the rectangle shown, but a different area. Okay, so our rectangle shown, first we're going to find the perimeter of the rectangle shown. 6 and 4 is 10, and 6 and 4 is 10. 10 and 10 is 20. So, and the area, 6 times 4 is 24 square inches because our units are inches over here. Draw and label a rectangle has a perimeter of 20 inches. So we need it to add up, all the sides need to add up to 20 inches, but a different area. So here's what I'm thinking. I need 4 sides, right? So let's say I'm going to make these 2 sides be 2 units long. Okay, so those two added together would be 4. So if I take 20 and I subtract 4, because I have 2 and 2, which makes 4, I would get 16. Now, 16 has to go amongst these last two sides. So what plus what equals 16? Hopefully you're yelling out that at me. 8. 8 plus 8 equals 16. Okay, so if this is 8 and this is 8, we will get 16, right? So let's double check. If I do 2 and 8 makes 10, 2 and 8 makes 10, 10 and 10 is 20. So my perimeter for this rectangle would be 20, right? 20 inches. Okay, so now that we have an example of a rectangle, a 2 by 8 rectangle, that has a perimeter of 20 and an area, let's figure out the area, equals length times width. So the area equals 2 times 8, and so that means the area is 16. Is that equal to the area of the first one of 24? So we did it. What is the length of the area you drew? 8. What's the width? 2. And the area is 16 square inches. Okay, so that's kind of cool. Let's try another. Describe the length and width of a rectangle that has the same area as the one below but a different perimeter. Okay, same area. So first let's find out what is the area. Area equals length times width. Area equals 8 times 3. So the area of this shape is 24 square yards. Okay, 24 square yards. So let's find one that has the same area but a different perimeter, so we better find the perimeter too. Okay, so the perimeter for shape 1 equals 8 plus 3 plus 8 plus 3. 8 and 3 makes 11. So our perimeter is going to equal 22. Okay, so same area, different perimeter. So I need to think of what other numbers multiply together to make 24. So for 24, like what are the factors of 24? I could do 1 times 24. I could do 2 times 12. I could do 3 times 8, but I couldn't because that was already used. I could do 4 times 6. Look at all these numbers that multiply together to make 24. Are there any more? 5, no, 6, yep, already got it. I think that's all. So I just need to pick one of these. I cannot pick this, so maybe let's do 4 by 6. Okay, so to describe the length and the width, we would say the length is 6 yards. The width is 4 yards. It has the same, and so let's make sure, what would the perimeter of this, of a 6 by 4? So we would do 6 plus 4 plus 6 plus 4 for our perimeter for shape 2. So 6 and 4 is 10 plus 10. So our perimeter of shape 2 would be 20, and the original one was 22. So we have a new rectangle that has the same area but a different perimeter. Okay, so this information that I got here was from a rectangle that was 4 yards by 6 yards. Okay, let's try another one. All right, so we're going to start with number 2 here. Draw and label a rectangle that has the same area. Remember, area is multiplying, but a different perimeter than each rectangle shown. So this is like the last one we just did. Oh, and look, it's the same. This is the same, so we better pick a different one. Let's do, remember our area equals length times width. So we need to do 8 times 3 to get our area. And that is 24. On the last one, we kind of listed out for 24. I could do 1 times 24, 2 times 12, 3 times 8, 4 times 6. So we've already done these two. Let's do a 2 times 12 rectangle. Okay, so we're going to have 2 and 12, and this is centimeters is our unit. Okay, so 2 times 12 is 24, so we're going to get the same area, but we need a different perimeter. So let's see, what is the perimeter of this shape here? So I'm going to do 12 plus 2 plus 12 plus 2. 12 and 2 is 14, so I have to double 14 to get 28. Okay, and if we look back to our last one, this perimeter was 22 centimeters. And now we're at 28 with a 12 by 2 rectangle. So here's what I'd hope you noticed. The farther the numbers get away, like 12 and 2 are pretty far away, and it has a larger perimeter than this rectangle up here that has an 8 and 3. 8 and 3 are a little closer together than 12 and 2, and the perimeter is less. So the closer together your numbers, your length and width, the smaller the perimeter it gets. Isn't that kind of interesting? So let's look at this next one. So our area equals length times width. So I need to multiply 9 and 1, which is an area of 9 square yards. Okay, I should have done square centimeters for this one. So what numbers do we know that multiply together to make 9? 9 and 1 or 3 and 3, right? So our next one's going to be square, and it's going to be a 3 by 3. 3 yards by 3 yards. So what would, we know the area is already 9 because 3 times 3 is 9. So let's find the perimeter. 3 plus 3 plus 3 plus 3, 6 and 6. So the perimeter equals 12 yards. This perimeter for this shape is 9 plus 1 plus 9 plus 1. And so that makes a perimeter of 10 plus 10 or 20 yards. So again, the farther away the numbers, 9 and 1 are farther away than 3 and 3, right? 3 and 3 are the same. And so the farther away, it makes a larger perimeter than if it was close together. Okay, let's try some more. David's dog pens uses the rectangular dog pens shown in the table. Use the information to solve exercises 4 and 5. Which dogs will take up the same area? Okay, so we're looking at 8 times 6 because area is length times width. So for dog pen 1, area equals 8 times 6. So our area is 48. Okay, so for pen 2, I need to multiply 10 times 4. So area for pen 2 is 40. For pen 3, I need to multiply 8 times 5. Area equals 8 times 5. Area, then 8 and 5 makes 40. This should be square feet, square feet, square feet. Okay. So which 2 pens take up the same area? That would be pen 2 and 3. Take up the same area, which is 40 square feet. Which dog pens have the same perimeter? Oh man, which has a greater area? How much greater? Oh, we can answer the second part. Pen 1 has the greater area. How much greater? Well, we better write it out. Pen 1 is the greatest. Area, how much greater? By 8 square feet. Right, because they're 40, pen 1 was 48. Okay, let's go back to the first part. Which dogs have the same perimeter? So let's find the area of, or the perimeter of the first pen. So I'm going to do 8 plus 6 plus 8 plus 6. This is our perimeter. 8, this is a 6, sorry, my terrible handwriting here. Okay, 8 and 6 makes 14 plus 14. So the area or the perimeter of pen 1 equals 28 feet. For pen 2, I need to do 10 plus 4 plus 10 plus 4, which is again 14 plus 14. And the perimeter is 28 feet. How about that? All right, pen 3. 8 plus 5 plus 8 plus 5. Okay, 8 and 5 makes 13. 13 and 13 makes a perimeter of 26 feet. Which pens have the same perimeter? Pen 1 and 2 have the same perimeter. So 2 and 3 have the same area, but 1 and 2 have the same perimeter. How about that? And the perimeter is 28 feet. How cool is that? All right, let's do some more. Alexa drew a rectangle with an area of 36 square centimeters.
Answer your question. The area.
Okay, that's funny. This problem has Alexa, and my Alexa was listening to me read the question. I better be a little quieter talking about her. Okay, so the rectangle she drew has the smallest perimeter possible for this area. What is the length and width of the rectangle she drew? Okay, remember what I've been saying. The closer the length and the width are, the smaller the perimeter, and the farther the length and the width are apart, the larger the perimeter. So we want two numbers that are super far apart to make this we want the smallest perimeter. Sorry, I thought we want the largest. So we want numbers that are really close together to make the smallest perimeter. So remember when we did that problem where it was a 3 by 3 square, and so then we just had to add 4 3s together? I wonder if there are any numbers that multiply together to make 36. Well, let's first figure out what are they. So I could do 1 times 36. That's really far away, going to make a large perimeter. 2 times, let's see, 15 times 2 is 30. And so I should do 18. 18 times 2. 3 times 12. 4 times 9. 5, nope, 6. Yes, 6 times 6. Okay, so the closer the length and width are together, the smaller the perimeter. Let's choose that one. Okay, so what is the length and width of the rectangle she drew? The length equals 6 centimeters, and the width equals 6 centimeters. Let's just check, like this perimeter equals 6 plus 6 plus 6 plus 6, so 12 plus 12 is 24. So the perimeter is 24. Let's try the next closest one. This perimeter is 4 plus 9 plus 4 plus 9. 4 plus 9 is 13, plus 13 is 26. Notice, as they're getting farther apart, the larger the perimeter is getting. Let's try 3 and 12. Let's go over here. So the perimeter is 3 plus 12 plus 3 plus 12. 3 plus 12 is 15 plus 15. Our perimeter here is 30. Okay, as the numbers are getting farther apart from each other, the larger the perimeter is getting, right? And imagine this, for a perimeter of a 1 by 36, I have to add 36 plus 36 plus 1, right? That's going to make a huge perimeter. So anyways, we would want to do this one because that's going to make the smallest perimeter possible. Test practice. Which rectangle has the same rectangle area as rectangle E, but a different perimeter. So 9 times 4, so rectangle E, we would do area is 9 times 4. So for rectangle E, we would get 36 square units. Are there any other numbers up here that multiply together to make 36? 8 times 5, 40. 10 times 3, 30. 7 times 6, 42. 6 times 6 is 36. Okay, so that means that for rectangle A, the area, 6 times 6, the area is 36 square units. So, rectangle A. That is all I have for you today. This is kind of a tricky concept. Okay, so don't beat yourself up if it's tricky and you're like, I'm not quite sure. You could try watching it again. Maybe now that you've gone through the work and you could just watch and listen, kind of pick up some things. But just do your best and we'll keep working. All right, so let me know if you have any questions. I'm happy to help. We'll see you tomorrow.